Hi everyone, welcome to the coding section of your linear regression with machine learning modules section. This is going to be a two-parter, guys, because we're going to do a little bit of reminder and review in this first part, and then go and look at some of the, in the code, but also then in the second part start running the code and looking at some differences in there. So by the end of part 2, you're going to have a bunch of all of this learned. You're going to learn a little bit about how to build a machine learning model using multiple linear regression. Most of this class is going to be focused on doing some Python fundamental reminder with machine learning, as well as how to split our data using a useful function. And then in part 2, we're going to put all this stuff together, remind you about how visualization works with matplotlib, as well as how to build our machine learning model with multiple features, as well as go over some of the pitfalls and issues with just using default parameters. Some things like normalization and overfitting are going to be topics that we're going to bump into in this section that eventually we're going to get more nuanced with and try to deal with as we learn more about how the dynamics of machine learning are working. So with that, guys, why don't we just jump into the syntax of this machine learning model, and I can show you what's going on there. All right, so here we are, guys. The first thing we're going to do is we import a bunch of different functions into our Jupyter notebook. If you guys don't have a Jupyter notebook, you can just do this in Python with regular scripting. However, if you want to follow it exactly like I do, I would recommend downloading Anacondas and pulling up a Jupyter notebook and running through this with me. So the first thing I do is we import our pandas library. Pandas is for using manipulating data frames in Python. So it's a great way to take in some data and manipulate it and use it almost like you would in R or some other language. Next, we import matplotlib because I want to have our visualization functions ready to go. And then we import a bunch of scikit-learn functions. So the first one we import is their sample data sets. This is so that we can, do our testing and try out these models. Then I also import the linear model function in scikit-learn, so linear regression modeling. And then the last thing we import from scikit-learn is our train, test, and split function. So what this function does is if we give it some data and tell it some parameters of how we want the data split and tested, it will return our training and target variable objects for our machine learning model, rather than us doing some sort of difficult for loop process. It'll also randomize what it selects for training and what it selects for testing. So it's just a really useful function to in one line break up your data into the parts that you need in order to run a machine learning model. So the first thing we do is we create an object in Python. We use the assignment variable here, and we use the datasets function that is available in scikit-learn. So we call datasets, and then we use the .load diabetes, which is the diabetes dataset that is in scikit-learn. So this becomes an object that we can then pass into pandas to convert this object into a data frame that we can manipulate data. So basically, this diabetes dataset is essentially a NumPy array of a list of lists. It's an array of information. So when we load our data frame, what we're doing with this scikit-learn object is we're saying that the data frame is this thing called data, and then we pass in the column names. And if we go to our diabetes object and look at the different functions available to it, feature names is one of it, and that provides a list of all of the columns. So this line converts our scikit-learn data file into a pandas data frame that we can then do easy manipulation on, because pandas is kind of designed to manipulate data in simple ways that we've been using in many different languages. So the first thing we're going to do is we're going to conduct a linear regression using only one parameter, so that I can recreate that line I showed you in the first class to show you that okay, we made a correlation between BMI and the score, which is our diabetes score. It's an arbitrary number. I'm not really familiar with it. And we also took a couple other things that we wanted to look at with that as well. So the first thing we do is I create an object list with one feature in it. I call our features, and I say I just want our body mass index as an important feature. Okay. And so what we do then is I say, okay, the data that we want for X variable are all the feature names for all columns with this list of feature names. So it's just one column at the moment. I then, if we look at our diabetes function, again, if we do .target, that is basically what our Y data is, our training and target. So basically what we use, the language that we use to describe our X and our predictor. What is our target output, if you will. So that's all that's doing right now. It's basically these two lines are creating our X and our Y data. This creates basically a list, and this is a pandas data frame with one column. The next thing we do is we split our data into our training and testing. And if you look at the train test split function in scikit-learn, there are a few parameters available, but the ones that we're doing is first you pass in your X, you pass in your Y, and one parameter that is a default one, but I'm adjusting here, so I'm saying test size equals 0.2. What this is saying is I want to keep 1/5 of my data not to be used for training. I'm not going to get my machine learning model to learn anything from 20% of my data. And the reason for that is because I'm holding that data to test it after it's learned. And why we want to do that is because we are concerned with something called overfitting. And I'll spend more time talking about that as we go on in other lectures. Basically, with overfitting, what that means is if we give it all the information, it might learn, it might not actually be learning what we want it to learn, the process, but it might just be learning everything like the most optimal aspect of the data. So we keep some information away so that it hasn't learned on it at all to see if unlearned information is also giving the pattern of responses that we were hoping for. There is a more complicated way to build training and test data, which is going to be a whole chapter of our class later on dimensionality reduction. It's going to open up one of those processes that I talked about previously. So, okay, we have created basically 4 chunks of data. These are lists essentially, where we have all the it's an embedded list, so a list of lists where each embedded list is the data for our X variable, which is just one value in there, but there could be multiple. We then have our test data, which is extracted away from training, and we have Y train and Y test, and all of these variables, the order positions are related to each other, so that the first value of X train corresponds to the output of the first value of Y train, and same with X test and Y test. So it selects each of these train and test, each of the X and Y variables for train and test, and puts them in order in each of these group objects. Okay? The next thing we do is we create an object which has our linear regression modeling function packed in, and we create that object with its default parameters. So now what we can do is say linear model, let's teach our linear model something with some training data, and we give it our X and Y training data, and that the result of that object that's returned ends up being basically the parameters, the mx plus b function, the m and the b. It's found its optimization. So then what we can end up doing is passing in some test variables, so some things that it weren't trained on, to get a set of predictions, which are what the model is learned and what it expects the result should be. And what we can do is we can compare our predictions to our actual values, how close they were, and actually see the mean squared error difference. So why don't we start running some of this code and get into this other stuff a little bit out. All right, guys, and on that note, we're going to call it for this part of our coding section. In the next section, we're going to actually run some of this code and see how it's all working. So you just saw how to build a machine learning regression model, multiple linear regression model using machine learning. We did a mostly a reminder of our Python fundamentals, and then I talked a bit about splitting our data into training and testing. In our next section, we're going to do more on the code itself. I'm going to show you like how all of this is actually working under the hood by doing some basic descriptions, watching the, printing some objects out and plotting as well. So next section, we're going to spend a lot more on visualizations and comparing calculations between these models and seeing how it's all working. So see you there.